right, so now let's look at an application of using a cylinder and possibly a sphere or some other one figure we've talked about. So I'm going to have you go ahead and read through this problem and underline or write down any pertinent information. Okay, so what we're doing here, ladies and gentlemen, is, as I've always said, when you do problems like this, you got to figure out a couple things. First of all, you got to figure out what type of figures you're working with, and secondly, does that involve lateral area, surface area, or volume? If it's lateral area or surface area, then generally you're talking about the outside of the object. If you're looking for volume, you're thinking about how much does it hold, or you're filling the object. So if we take a look here, since it says how many gallons of water does it contain, I'm guesstimating we're going to be working with volume, okay? Because we're going to end up filling this object. And then what are we filling? Well, actually, you're looking right here. We're filling, if you read the problem, it says how much water will it hold to fill the top of the cylinder. So here's the top of the cylinder right here. So basically, you're looking at the cylinder and half a sphere. So we're looking for the volume of a cylinder and half the sphere. And I'm going to draw that half the sphere. Half a sphere is called a hemisphere, and that's what it says right here. So whenever we find the volume of that cylinder, we're going to divide it by 2 or multiply it by half. So let's go ahead and let's start. We're going to find the volume. Let's start with the cylinder right here. This is a cylinder. So we want to find the volume of this cylinder. Because remember, we're filling it with water. So the volume for a cylinder, and I'm trying to look here, we're given both, if you take a look, we're given the height, which is right here. This is the height, 16 of the cylinder. And we're also giving the diameter of the top of it. Now, again, if you can't see it, maybe you can, I'll draw it down here. It kind of looks like this. So the diameter here is 20, and if it helps to 20 feet, and if it helps to write it out, ladies and gentlemen, or draw a different picture, you sure can. Now, this is the bottom of the cylinder. It's not the bottom of the hemisphere, but again, that's also a diameter of 20. Or you could say this, it has a radius of 10, whatever you want to use. So to find the volume of a cylinder, we're going to go ahead and take area of the base times the height. Or if you go onto your formula sheet, that's pi r squared. That's the area of the base, the circle. Base, again, I'm talking about being here on your cylinder or down here. I'm not talking about the half sphere at the bottom, times the height. Now, so we're going to get volume equals pi, which you can use just the pi button or 3.14 on your calculator. The radius. So I'm using the radius. Now remember, the diameter was 20. This was the diameter. So the radius is 10. Okay? So the radius is 10 feet. So I'm going to use 10 squared times the height, which was 16. And if you do that, you get, let me get my calculator out here, people. Again, I'm just going to use the pi button. So I'm going to take 10 squared as 100 times 16 times my pi button. If I can find it on my calculator, there it is. And that is 5,026.548, yada, yada, yada. We don't have to go too much further because remember, we're going to round to the nearest 100 gallons. So really, I can just put down 5,026 if I like. And again, that would be cubic feet. That's how much is filling this cylinder right here. Now, let's find out how much fills half this sphere down here. So this is what we're going to find next. So what we're going to do is we're going to find the hemisphere. Well, all you need to do is take your sphere formula for volume. Volume equals 4/3 pi r cubed. And that's, again, 4/3 times pi, the pi button, or 3.14, times the radius cubed, which would be 10 cubed. So if you do that, let me do this also. I'm going to use my fraction button, 4/3 times pi times 100 cubed, which would be 1,000. And you get 4,188.79 ... Now the thing is, again, it's a hemisphere. So what we need to do is then we need to take that volume to find the hemisphere and divide it by 2. So I'm going to take 4,188.79 and divide it by 2. And I'm going to have to extend my page here. And we get approximately, divide that by 2, we get the hemisphere would be, the volume of the hemisphere would be 2,094.395 ... And I'm just going to use a whole number because we're going to the nearest hundred. I'm going to use 2,094, and that would be feet cubed. Okay? So, what do we do now to find the total volume? We just add those two numbers together. To find the total volume, we're going to take this number and add it to this number. So, total volume is equal to 5,026, the volume of the cylinder, plus 2,094, which is the volume of half the sphere, the hemisphere. And we get 7,120 cubic feet. Now, the only bad thing is, it tells us how many, it wants to know how many gallons. So we're going to have to do a little conversion. You're going to have to figure out again how many cubic feet are in a gallon. Well, if you go to your conversion sheet, or you just Google it, 1 cubic foot is equal to, here I'm going to put it in different color. 1 cubic foot is equal to 7.48 gallons. Now I'm going a little over my 7-minute limit here, but again, I want to finish this up. So I'm going to use a conversion. We're starting off with 7,120 cubic feet. That's what I had here. And 1 cubic foot is equal to 7.48 gallons. The cubic feet cancel out. So basically, you just take 7,120 times 7.48, which you get 53,300 or 257.6 gallons. Now, it's said around to the nearest 100 gallons. Right here is the 100-gallon mark. This is the tens. This is the, or excuse me, the ones, the tens, and the hundreds. So that's what we're going to round to. So if we round that, the 5 is going to round, this 5 is going to round this 2 to 3. So that's going to be a 3. This 3 stays the same. This 5 stays the same. And then we put 2 zeros on the end for placeholders in both the ones and the tens place. And that's gallons. So that tower, filling it up, that water tower should hold about 53,300 gallons of water. So if you have any questions, if you're, again, rewind this, go back through it, but if you have any questions, please let me know. Now, for the assignment, or the practice problems, I should say. If you're in the white book, day 1, these problems from A and B, please read the directions as to what you need to do. Problem C are the application problems. And again, I'll put the answer key online. You'll notice that for the blue book, day 1 is different pages, but same problems for day 1. For day 2, the problems are different numbers. 3 and 4 are the same as the white book, but instead of 9, 12, and 14, do 11, 14, and 16. It's the exact same problems as 9, 12, and 14. It's just they're numbered differently. And if you don't have your book with you, I did copy the problems from the blue book and put them online for you. Okay? So good luck. Let me know if you need anything.